Welcome, everyone. My name is Benni Jagere, and I'm coming live to you today from Belgium. So sadly, I would have loved being in Poland with you, but that's the way it is. I'll be talking for the next 50 minutes about troubleshooting Power BI report performance. But first, I do want to give a heartfelt welcome to a heartfelt thank you to all of the partners, because I organize events myself. I know how invaluable they are to effectively putting on these events for people and keeping them as low cost as can be. That said, who am I? My name is Benni Jagere, and I'm a senior data insights consultant at a Belgian consulting company called Real Dolman, which is part of the Inetum group, which is a global group. Senior data insights consultant, meaning I use fancy words to help customers get insights from their data and make sure that those insights are valuable and that they can take actions on those. How I do that depends from customer to customer. And yeah, it really depends. In my spare time, I am the co-leader, a co-leader for a Belgian user group called datamines.be. And we also do similar events like these. If you want to reach out to me, you can reach me on the social channels, Twitter, LinkedIn as well. And if you reach out, then I'll definitely do my best to get back to you. And I do have a motto, which is say no to pie charts. I think pie charts are overused and pretty much don't share the message that you want to be sharing. So that's why I'm not a big fan of them. But what do I want you to take home with you from this session right now? Well, I mainly want to make sure that you can leverage options, whether they're internal to Power BI or external to Power BI, to pinpoint some common causes. And then also give you a set of techniques to try to avoid these or actually solve them. But avoiding is better than solving, so preferably avoiding them. But in the end, it also boils down to a usable set of best practices that you can use. I want to stress that this is not a DAX or Power Query performance deep dive. You cannot do that in 50 minutes. That's something to begin with. But also, I feel like there's other people better positioned to start doing those deep dives. But why should we start troubleshooting performance? Well, it is quite simple. No one likes to wait. If you are opening an application or if you're opening up a website or something and you need to wait for about 5 seconds on this, then you're starting to get a bit antsy. It's not user friendly. You don't like it. And it's the same thing with reports. If you have to wait for too long to get the data back that you need, you start getting annoyed at things. But there are some more things on there as well when we're talking about troubleshooting performance. Works on my machine is the most terrible of replies of all. I've been guilty of doing that myself, I admit, but even in Power BI, this comes into play. Because, for instance, if you're creating a Power BI desktop file and you're making that on your own machine and you share that desktop file with someone else who has a lesser performance machine, they'll have a worse time of trying to get all the data loaded, trying to do some of the mechanics and the measure calculations in there that you have. So works on my machine definitely also comes into play in Power BI, and there's always a bunch of variables in there that make it not identical situations. But it's as well, it boils down to what's the context and what's the baseline. Context meaning, are you looking at an Excel file that has 7,000 rows in it? Or is this your ERP system with 2 million transactions coming in every day? What's the volume of the data you're working with? And well, what's the complexity as well? But as well, what's the baseline? What is the expectation of your user? Have they set a hard requirement on the fact that I want to have my data in 2 seconds and 3 seconds returned? Or are they a bit more lenient? So it's the combination of those two that usually put you over the threshold of, I have to start doing something about this. So typically, as I work for a consultancy company, I come into new clients and I need to gain their trust. But if you're not working in consultancy, if you're working on the payroll for a company and you're working in a team, it's the same thing. You need to gain trust. And gaining that trust is being able to quickly deliver some results, to have people realize that you have the potential of finding these things, and then being able to dive a bit deeper. So I typically go for these quick, small changes that I can instantly do that deliver some immediate results. And then after I've gained that trust, I'll go in a bit deeper and maybe come up with something else. So those long investigations on reports that are barely used are the ones that I try to avoid or push a bit backward as well, because it doesn't help anyone if I lock myself up in the basement for 10 days and come back with it depends, then no one is going to like me for what I've done as a result there. The exception that I do have to make is the fact that if it's C-level, CFO, CEO, COO, CDO, CIO, whatever O's we have these days, that's a different thing, because we actually they have the budgets, they pay the bills, so it's important to keep them our friends as well. But if I have to make it into a scientific formula, I'd say that troubleshooting report performance in Power BI comes down to, let's say, 40% science, knowing what to do, 40% art, having a certain flair of doing it, and having it in your fingertips, the Fingerspitzengefühl. And then it also boils down to 20% luck, might even be more sometimes. You cannot know everything. Everyone has to keep on learning to keep finding these new insights as well. Sometimes you just have to try something. And if it doesn't work, then work your way from the top to the bottom or the other way around. Just go procedurally through the chain. But I am a consultant, so it depends. Performance troubleshooting is always based on a number of variables, and it's always something to do with it. But let's dive deeper. Before I do go on, there is this thing that I need to explain, and it's this concept called noisy neighbors. And noisy neighbors may also have been used in different contexts than Power BI, but especially in Power BI, they come into play when we talk about this thing called shared capacity. And shared capacity is actually Power BI Pro or Power BI Free, the standard licenses as well, which means that we're using a set of shared resources across the different organizations that are located on that data center. Mind you, those resources are massive, and they are well able of handling whatever requests we throw at them. But it might also be that because of these shared resources, some data set refreshes will not be exactly as fast or exactly as slow as the last time. There's always going to be some margin of difference on there. It's also possible that our data set has to wait for about 10 to 15 minutes to wait for a slot to be able to refresh in there. So it is bothersome that you don't have control over that, so that you have to share those resources. But it's also the fact that those resources are massive and they can effectively handle whatever we throw at them. And you have to think less about managing those, about governing those. It's less of a concern. And premium capacity, the V1, because it's all about to change, it doesn't automatically solve all these problems, because premium capacity is dedicated capacity where you get a set of resources specifically for your organization. But then you have to start thinking about managing these things as well. And if you do not do this, then you'll probably have a very bad time. Premium is also going to change in the next coming, well, it's already changing, and it's rolling out to multiple organizations in preview right now. So premium is also going to be shared capacity, but shared plus capacity with bigger and better machines, better equipped to handle the needs that we have. And then the last one, that's the most important one that you need to take home with you today, is beware of caching mechanisms on all levels. Caching happens at a lot of places, and they can affect what you're doing positively or negatively. But I have a set of reports, and I'll gladly show them with you. So I come from the city of Antwerp in Belgium, well, close to, and I went to school there, and we have these things called vélos, which pretty much means bike in French, but we use it as a dialect word as well. And those vélos, you can pick them up from a station and put them back, and then just do that as well. So I asked the city of Antwerp for the data. They wouldn't give it to me. They only would give me aggregates. I didn't want that, so I went looking for some other data, and I stumbled upon the New York City bikes. And the New York City bikes is pretty much the same thing, but a lot bigger, because they have much more bikes, and they also have more stations. And they have open data for this starting at June 2013, and they release a new data set every single month. So by now, it's standing at about 100 million transactions, which means that it's actually a pretty nice data set to do some digging and some tweaking on this. And that's also why I use this. So that data contains every single trip that's happened for longer than 60 seconds, and trips that started at a public station. So not servicing, not maintaining, not tests, not those kinds of things. And it also contains master data, information on stations, on regions they have, those kinds of things. So it's actually pretty nice to build out a star schema. So I have built myself a report on top of that. It is purposefully not the most beautiful report I've ever built, just to be able to explain some things to you on why I've done some bad things. So as soon as I click on this, my report is going to start rendering, and it is going to take a very long time to render. A bit way too much before this actually starts rendering. And why am I showing you this? Well, it's pretty much just because I want you to see what the report is. And it's a bunch of key figures on it, a simple map about it, and then a line chart, and then a matrix that's overly detailed, and that's going to take about 30 seconds in total just to completely render. So not the most beautiful report I've ever made, but specifically one that I made with some things to keep in mind things that I commonly see occurring on reports that I assess from other people. So what are we looking at? I also need to close off that Power BI desktop file. So what are we looking at inside of Power BI Desktop? Because Power BI Desktop contains a bunch of services that you may not have been aware of. And that's what I also discovered when initially doing these things, starting to review these things a few years ago. Because if you look at Power BI Desktop from inside your task manager, you can see that there's actually a bunch of these things called in there. And there is the one important one, that's the SQL Server Analysis Services engine, which is pretty much an SSAS instance running for every single Power BI Desktop file that you have open, which is pretty cool because it automatically starts, it automatically stops, and it takes care of loading and processing all of the data in the model, which is, well, you may have not always been aware of it. And then there's these things called the Microsoft Mashup Evaluation Container. Well, and they are used for Power Query files, Power Query queries that are inside of our Power Query, meaning that there are containers and they can have a certain size. And if you load data in there, they'll be dumped into a container. The data will be processed in there, and then it will be loaded to our Power BI model, which is also something that you may not have been aware of. And then what we also have as well, and that's what really starts being interesting, is this: we have these things called the C#, so C# browser subprocesses. And those subprocesses, they are actually used to render our visualizations. That's what being used to render the different visualizations on the front-end side. And what's interesting to know about these as well is that this process in some form also gets kicked back to the end user browsing the report. So the rendering of the report is bumped back to the user browsing the report. And what I said works on my machine, that's especially this, because if they have a less performant and less graphically capable machine, they will have significantly worse performance when rendering these visualizations. So that's important to keep in mind as well. And then because of the fact that I blew my things a bit, is you also have this thing called the console window host. And that pretty much is a console program in C, written in C++ or C#, I forgot, which ties all these things together. And that's all running inside a single Power BI desktop file, so that you may not have been aware of this. Which also means that when we're loading these Power BI desktop files and we're sharing them across different PCs, that's when these resources also come into play. The most commonly one is the analysis services instance, because if you have that on your computer running locally, this is likely going to eat up a large chunk of memory. So this is something you really need to keep in mind. But when I do need to go start looking into these things, well, I have a set of tools that I use pretty much. And my number one, my go-to, is the Performance Analyzer Pane. And this is something that's been released in May 2019, and it drastically made these things a lot easier. Pretty much, it's a flight recorder for all the operations happening in there. And what it does is it breaks down all the execution times based on a few categories. We can order them, we can view some details, and we can also export these results. So for instance, when I'm not working at a customer, I'm somewhere else, instead of having to ship over the entire Power BI file, they can just send me the export. I can browse through the export of this Performance Analyzer Pane, and then I can tell them, well, you need to look at this. This is probably giving you some issues. So having someone help you from a distance really does become easier with this. And before this Performance Analyzer Pane existed, well, you had to do some tricks with trace files on Analysis Services Engine in the backend, and it wasn't that efficient. So it's changed a lot since then. So if I do want to get started with this Performance Analyzer Pane, and if you're running in a version that's on the new icon and the new ribbon, you'll find this under the View tab. And when you're in the View tab, you can go all the way to the left, and you'll have this button called Performance Analyzer. And Performance Analyzer opens up a new pane, and that pane you can use to start recording. So that means that by now, every single visual that's being rendered, every query that's being opened, will show up inside of this screen. And I also just noticed that I borked it a bit, which is a pity. Usually I start this from the empty page, and then I come back to here, and then it takes the longer time to render. But since I've not done that now, it'll be a bit quicker, but still take a significantly longer time. So what we're seeing here is the fact that there is a total duration for all these different things. And the total duration is an important one. But the first one that I want to start with is actually the one that I usually see the most. Let's say if I open up one of these visuals, I can see that there is 3 different wait types. You have the DAX query, you have the visual display, and you have the other category. So DAX query is how long does it take in milliseconds to get your data from your model. Visual display, how long has it taken your front-end mechanism to render the effective visual. And then the other category, which is currently at 1.5 seconds of the 1.6 seconds, well, that's pretty much, it's pretty much parallelism at play, meaning Power BI and the desktop can only handle about 4 operations at the same time. And if you dump multiple operations in there, they'll have to wait for the previous operations to be finished. So what I usually see, is when people start placing a lot of these single card visuals on there and a lot of graphs on there, and then some text boxes and slicers and a lot of different elements on one single report, this other wait type will go through the roof. And there is nothing that you can do about it except for decreasing the total number of visuals you have on there. That's the only thing you can do. That's the only thing you can do there. So there are some techniques and tips out there to start working away these single card visuals to a matrix and doing some visual styling on them. And the one important takeaway as well is that every single text box you put on here also needs to be rendered. And I've seen cases out there. I think Phil Seamark did one Chris Webb did one as well with 250 text boxes on a single pane without getting any data. And just rendering those 250 text boxes took about 1.5 minutes or something. So each of those single elements needs to be rendered. And if you want to have text boxes and rectangles and those kinds of things, it can actually make sense to start making a layout in something like PowerPoint or Creative, whatever from Adobe, to just make a single image and have that being rendered in the backend. So it's all these different things that you can do to still keep your report visually attractive, but also make it performant at the same time, because it needs to be a blend of these two. But if I wanted to say, well, I want to know which one of these queries took the longest time, so I have to sort them descending, took the longest time to render visually. Well, to no surprise, the rendering visually the longest time is the map. So if I click on this, it will highlight the visual, and this is effectively the map visual that I'm using. So why did I pick the map? Is because I also see a lot of maps out in the wild, which is good. But you have to be aware that all these single circles have to be plotted and rendered individually. So there's about, I think, 1,500, 1,700 circles in there in total. They all need to be rendered individually, which can take some time. So am I saying that maps are bad? No, you need to be aware of what you're doing. Test these things, look at how they're rendered visually and how much time they're taking. And as well, this is the standard Bing map. But if you can, it's also an option to look at the Azure Maps preview map right now that handles usually performance a bit better as well, or looking at some of the custom visuals out there from the IQ map by James Dales, for instance, those kinds of things. But while I do reach the topic of custom visuals, even if it be very briefly, you have to be aware that custom visuals take a small performance hit. Because of the fact that rendering and logic can take place externally from Power BI, it takes time for the round trip, but they also use the external APIs for that, meaning that they have some more checks built in there and they go marginally a bit slower. So that's something to be aware of. So are custom visuals bad? No, you have to be aware that they can take a bit longer to process your results. That's everything that I need to say about it, because you can do some stellar things with custom visuals. So we have the visual rendering as well. So it boils down to knowing what visuals you're using and how compute intensive they are on the visual side. Because like I said, the rendering visually gets sent back to your end users and this local machine. So the overly detailed matrix, I'm not going to spend too much detail on this because otherwise I'll definitely run out of time. Well, what's happening here is there's just too many details inside of this matrix. I see people abusing this thing like an Excel sheet where they just dunk in 150,000 rows into a single matrix. Well, of course, this is going to take a bit longer to start rendering things. So think about what you're putting inside of a single table or a single visual. Think about the details you're putting in there, because it may actually be a bit better to, instead of having them just dunking this entire details on them, it may actually be better to give them some drill down, drill through options and start having them filter results before getting to the detail table. So it's one of the common things I also see is that there's too many details on a single visual. But what do we do with the DAX queries, for instance? So if I take this one, for instance, the card total trips Q to D, I can take the query and now it's in my clipboard. So I can go to Notepad++ and start opening that query, but it doesn't have highlighting syntax. It doesn't work that easy. So this is the part where I actually go to some of the external tools. And again, with the release of this tab called External Tools, this has become a lot easier. Because before, well, a lot easier. Before you had to open up a second window, you had to open up application and to connect manually, but that's all fixed these days. Because right now, I can just open up DAX Studio with a single click and it will automatically connect to the model I need to use, which is a lot more easy. So if I've done that, this is going to connect right now and I can paste my query in here and I can start analyzing these things. So within DAX Studio, we can see the exact same tables that we've been using, the model we're connected to, what the internal engine is for this Power BI desktop file that we have opening, and then we can start doing things. But I do want to stress again is start clearing your cache. Clearing cache before doing anything in DAX Studio is a really important one as well, because I want to look at the worst possible performance. That's what I want to do. So clear the cache. I tend to just click the button a number of times. And then if I execute this query, this is going to give me back the result that I expected with the current context that's in there. And I can look at this. So, okay, it's not too big of an issue with this query, but let's say that I had a query that does have some issues. Well, then I can look at this thing called the server timings. And the server timings give us some insights into what's happening on the internal. So I'm not diving in too deep because, like I said, it's not a deep dive on the internals of DAX as well. But I do want you to have some understanding of what's happening in there so that you can get started yourself. So if I've cleared my cache again, yep, and there we go. And if I execute my query, this query is being executed, and this is now going to show me some results. So there's some things here that may be interesting, that are interesting to us, because there's this thing called FE and SE. So storage engine and formula engine. So the storage engine is pretty much where the data is physically stored inside of these column store indexes in the VertiPack engine. And this storage engine is capable of doing very fast, simple operations, mins, maxes, some simple aggregations, summing, those kinds of things, really, really quickly. And then we have the formula engine, which handles some more complex things, but it doesn't use the stored data directly, because what happens is when a request is launched that the storage engine cannot do itself, it's pretty much going to prepare this little set of data called a data cache, make that available inside of the memory as well, but it's uncompressed, so it's the raw data. And then the formula engine does its work on this. It's going to do those complex operation and return that. So typically, when you see a high workload being shifted towards your formula engine, that's when you know that there is a lot of complex operations happening that cannot be covered by your storage engine. And personally, I prefer to have my model as covering as possible for what I'm trying to do inside of my viewports. So you can go deeper in as well and see some sort of the SQL queries that it's trying to do, and you can really go into some cool stuff here. But I'm keeping it very, very light on this topic as well, because like I said, it is very hard to cover this in some simple 50 minutes. But there are some resources at the end of my slide deck that you'll get that you can start using for yourself to start digging deeper into these things. So if I close up DAX Studio for now and go back, typically when I start an assignment with a customer, I have a standard set of tools that I use. And depending on the customer where I am, depending on what I can install from that customer, depending on if they have a paid license for these tools, it differs a bit. But that said, usually Performance Analyzer Pane is my #1 to start with, because I want to know which of the visuals is acting up. Pretty much always as well is the DAX Studio and VertiPack Analyzer, but I'll get back to that as well, and Tabular Editor. Those are usually my 3 groups of tools that I always use if I can install them. And if I cannot install them, well, then I need to go look at some different things that run locally. But mainly, for about 90% of my cases, these are the 3 main tools that I use. But there are a bunch of different tools out there. This is not an exhaustive list, by the way. There are multiple tools out there that can help you fit the needs that you may have. But I mentioned VertiPack Analyzer. And VertiPack Analyzer, if you've used DAX Studio before, is also located inside of DAX Studio. But I'm a bit old school, and I shouldn't have closed PowerPoint. I'm a bit old school, and I still run the Excel version. Why is that? Well, there are some details in the Excel version that you cannot find inside of DAX Studio yet. And if I'm digging deeper, those are actually the ones that I do find interesting. So if I go over to my, let's say, if I go over to my folder where I have these files listed, I have these VertiPack Analyzer files. And these VertiPack Analyzer files, they connect to the internals. So for instance, I know that this is the one that matches with the report I'm using, but I'll open up one of the earlier versions as well. So I can use that. I open up, and it's opening on my second screen right now, so I'll drag it over. So this gives me a pivot table, and this pivot table is connected to my internals of the model, and I can start using this to start looking at what's the internal of my model like, what's happening inside of my model. So I mainly have, it's taking some time here, I mainly have the largest part of my model is based inside of my trips table, which is logically because it has the highest cardinality, it has the most data in there. But if I go ahead and look into my trips table, and if I want to see how much of these how much of the table is being used by specific columns, I can go ahead and look at to see which specific columns are being used. I can look at what sort of encoding is being used, if it's hash or if it's value, and it gives me a lot of these things that I can actually start using to look at these things. So usually I look at these things. What's the cardinality of my table? What's the cardinality of my column? What's the dictionary size for these? And then what's the encoding? What's these different things in there? So I usually start looking for fields that have a high dictionary value. So the dictionary, real short, is what the model uses in the backend to make the translation between the column store format, the way that it stores its engine and its data in the engine, and the way that it's being fed into there by usually relational databases or Excel files or something. So bluntly put, it's going to store each unique value one time, and then it's going to create a dictionary. And that dictionary pretty much contains a pointer saying row 5 to 25, contain that value, 25 to 750, contain that value, and make that dictionary, that translation file for you. So if I'm seeing a high dictionary file, that means that I have a lot of unique values, and that it's taking, that I have a lot of unique values for that, and that it's taking a lot of time to process these things. So these highly unique values, like start time and stop time, they're usually my go-to suspects, especially because of the fact that if you look at the sum of these two, well, that means that 86% of that table is being used for those two datetime fields, and 83.5% is being used for the entire database, for just simply those two fields. So that is a lot of unique values, and that means that it takes up a lot of space. So that's just one of the things, but I can also go ahead and start looking into compression, into the encoding details. So a lot of the internal information that you can look at, but you don't have to do that, because like I said, usually you can definitely get started with just looking at the tables and the column information and start from there. And you'll find a lot of things that you can fix before even going into these. I need to open up a different file, because also what you can find in there is a very simple way of finding what calculated columns are listed inside of your module, because it's scraped the entire internals and it's giving you every single one of these that you need to know about. So that's pretty interesting to know what's just happening inside of the model with a few clicks to set this up, and then you can refresh it and you can have this information every single time, which is pretty cool, I think. And so using this Performance Analyzer to go diving into your internals is a really good way of getting started. And you don't have to dive deep in there. If you just look at these things and know, well, what's the cardinality, how much size is it taking, and then start thinking for yourself, do I actually need this? Can this be changed? That's a very good way to start. And that's also effectively what I try to explain to you. And I see some of the questions. I'll keep those for Q&A at the end, and I'll definitely get to those. So if I go back and look at the list again, there's one very big player in there called Tabular Editor. And Tabular Editor is an open source tool, sometimes called a fancy JSON editor as well, which connects to the model that we have, and then it starts deserializing that model. So it's going to generate a bunch of JSON files from those and start loading in those JSON files. It's offline, meaning that it gets those different JSON files when it's loading, connecting to the model. And because of the fact that it's offline, you can instantly make a lot of changes in there. So if I've opened up already my Tabular Editor, but if I connect to one of the files that I have, for instance, the local file that I currently have open right now, I can connect there, just use the Windows authentication as well. Use those Windows authentications as well. And it's going to connect me to that same model that I have. So it's the same tables that I've been seeing there. And if I were to be wanting to make some changes, I can go in there and I can start doing changes, and they'll instantly be translated because it's offline. And then as soon as you've made those changes, you can send them back to the model and then be done with it. So this is a real, especially because of the fact that it's open source, you can do some really cool stuff with it. For instance, if I were to say that I wanted to make a duplicate of them, then, well, it's now done. Or if you can do some of the real cool stuff with that and saying that you can do some of the advanced scripting, you can generate 500 measures if you were to be wanting that in a few clicks of a button. So if you want to go next level into developing those models, diving deeper into Power BI, into Tabular Editor is a definite recommendation. But my main reason for going to Tabular Editor right now is this thing called the Best Practice Analyzer. The Best Practice Analyzer can be found in the Tools window, and then you have this thing called Best Practice Analyzer. And what this does is it's going to run a set of checks on your model. And based on the fact if these checks fail or succeed, it's going to give you back some feedback. So there is a standard file. There is a standard file that that the creator, Daniel, has made for this. But you can also find on the GitHub page, and the link is included in the slide deck as well, you can also find rules that people have submitted. And by now, this is a really, really, really dense base of knowledge for best practices on tabular models and Power BI models as well. So if I just click on this, it needs to load in the rule file, apparently. Yep, there we go. So if I run this, this is giving me a list of things that I may want to be checking at, And with a few clicks, I effectively have an entire audit of a model. That this one I made myself, and this one I made some dubious things in there myself. But it also means that I can start looking at different things that may need to be changed, which is really interesting as well. If you're working on tabular models, if you're working on Power BI files that are using, hey Paul, I'm muting you. So if you're using these enhanced metadata format before, if you're using the Power BI desktop release after September 2020 and it's using the enhanced metadata format, you can actually go ahead and directly start applying fixes and directly start doing these things, which is pretty cool as well. And the best thing is that it's all open source. It's embraced by the community, and they keep sending new things in there. So it's a really interesting way to start looking at models that you may not have created yourself. So if I look at the things that I do, and let's say that people hand me a Power BI model, what I do is I run DAX Studio with the Vertipack Analyzer to check the internals. I run the Best Practice Analyzer to see if there's some things that may not be adherent to a set of standards. And those two things immediately give me a clear overview of the model and the way it's made. Which, if you'd had to go diving into these things in Power BI Desktop yourself, well, it's less ideal, to be honest. This will take you a much longer time to start doing this. So with a few clicks, you can actually start assessing a model and get these things, these insights as a report for yourself to start working on your specific troubleshooting points that you may have. But that's just how I get started. In the end, it also boils down to the fact that, well, there's a bunch of tips and best practices that I use to keep the models from, well, being a bit more performant and being a bit more well-formed. I have a few golden rules, which is pretty much about transformations. Transforming your data and the logic as early as possible, meaning that if you have a process flow where you have your Power BI, your model, Power Query, a source system, something else happening there, and as soon as you can have the data transformed, that's better, because if you don't need to make those transformations at the last minute, that means that they'll be persisted and that they can be used in all the next steps. So when you're talking about reporting scenarios, that usually means that your either going to be making them in the data warehouse, the data mart, the data lake, the delta lake, whatever you're using, or inside of Power Query at the latest. If you please, do not go start transforming data in DAX with calculated columns, because they simply do not perform that well. So as early as you can, but also just once, because if you're making a transformation in your data warehouse, well, it doesn't make sense to redo that transformation the exact opposite way inside of your Power Query, because you're then just doing things twice, and that's not as efficient as it should be. Which also boils down to the fact that make those transformations smart. Is that effectively the transformation that needs be? Is there another requirement? So it makes sense to start thinking about these things as well. So simple rules that really help you think about these things. It also boils down to data types. Data types is if you've been working with SQL for a longer time, it's the same thing. Data types matter. It's the same thing in Power BI. You really shouldn't underestimate the impact. Meaning that, do you have values that are configured as a text value but are actually numeric and they can be made an integer because they will compress a lot better? Do you really need all those unique values? Do you really need date and time combined into a single field, or can you split them together? Do you have decimal values that have 17 trailing decimal numbers and you only need 2? Those kinds of things. So thinking about the data that you're putting into your model will drastically impact your model size, but also the performance of these things when you're doing your transformations on the fly. Auto-date time, I didn't spend too much time on this as well, but auto-date time will generate a calculated table with calculated columns on the fly for each date time field that you have inside of your model. To give you an example of where it went really bad, I had a customer that loaded data in from an ERP system. That ERP system in that data set we were using had about 160 date time fields. If a date should have been filled in but wasn't for some reason, they set it to January 1st, 1900. And if a date was unknown and it had to be filled in later, it was set to January 1st, 2100. So the auto date time just takes the min and the max values, and it will generate a table for each and every one of those date time fields. So 160 times 200 years in a date time table, well, it's a lot of data that you don't really need. And auto date time is great for prototyping something simple, but you usually don't even need it. So it makes sense to go ahead and start to go into your Power BI desktop file, deactivate that setting, and then use your own date and or timetable to do this yourself. Column and row usage. Do you actually need all these different columns in there? Because what I see is that people just raking entire SQL views that have 85 columns in there, and they effectively use 3 or 4 of these things in there. Think about, if you're not using them, then you really need to start throwing them out of your Power BI reports as well. But it all boils down to, because I really need to start shifting gears, it all boils down to your model. And I, for Power BI, am a sucker for star schemas. Star schemas perform best with Power BI. Why is this? Well, because of the fact that the column store engine can do its best work when it's having star schemas, which means fact tables that only contain either a base value for a measure, an integer value for a key, and then your dimensions around them, which are small and straight to the point for those attributes that it needs to start configuring and start processing. But star schema as much as you can. Make sure that the surrogate keys are persisted, and surrogate keys meaning identity values or integer values. Please do not use GUIDs as your primary key inside of Power BI, because they perform bad. Bidirectional filtering is less than ideal, because it has to check the filter propagation and the context in both values, and that's potentially not as interesting, because it has to make those checks, and it can perform better, but it can also produce results that may not be as intuitive as you think. Auto date time should be disabled by preference. Rather just go ahead and mark them as a date table. role-playing dimensions, specifically for performance. Test it out, check it. If it's not about performance and if it's about preferences, well, good luck having that discussion, because people have very expressive feelings about either way, about having a role-playing dimension or having a physical dimension. So good luck with that. The data types that you're using, try to optimize them as much as you can, because they will definitely make a big difference for you. And then those white tables, try to keep them as narrow as possible. Try to keep them as concise. Try to keep them covering to the data that you need to be showing in the report, both for columns and the rows. If you don't need data from 2016, then don't load it, because it's going to be loaded every single time. And if you're not using it, it doesn't make any sense to have it there. And then if you're working for Power Query to your model, if you're not using that table, if it's just a staging table, then make sure that it's not loaded into Power Query, into your model. Make sure that the integer values that you have are set to do not summarize by default, because they also have a small hit on performance. And then your data granularity is something very much to keep in mind. If you're having, for instance, in the example that I'm showing, if you're having trips on a bicycle, do you really need every single trip, or can you have an aggregate based on the hour, an aggregate based on the day for the analysis you need? You don't always need the leaf level granularity. And if you can have aggregated data, that's going to be smaller and more performant to allow the engine to do its work. Not as much performance, but just some form of best practice is, well, try to keep those key fields, if they don't have a meaningful value for your end users, it makes sense to not have them inside of your model visible. So you can just hide them. And especially if it's a fact ID, it doesn't have any sense in there, you can remove that key, because it also will save you a lot of time on your model processing and on your query performance as well. I did forget about one single thing, which I do need to show you a bit more in detail, is I went through the steps of making that simple report that I made, where I started from the base file. And the base file is based on about 4 gigabytes of CSV files, and it just means that it loads Power BI into, everything is a text field, and it's loaded into Power BI Desktop, which means that it boils down to 960 megabytes, give or take. As soon as I start setting data types, you see it drop to 790 megabytes. As soon as I disable auto date time, you'll see that another 80 megabytes is dropped off, because it doesn't make those in-memory tables for each thing. When I throw out some of the columns that I'm not using, we'll see another significant drop to about 550 megabytes. And then, so the same columns that I have, but reforming them into a star schema, well, that went from about 550 megabytes to 160 megabytes. So the model is a lot smaller, but because it's a lot smaller, it can also fit better into the engine, it can also fit better into memory, and it takes less time to scan for those results that you need. So a smaller model is usually also more performant. And if you can have that star schema model be sufficient for the calculations you need to have, so you don't have to start dynamically calculating certain values on the fly for calculated columns, binary values, those kinds of things, then you'll usually have a much better performance in there as well. So that's what I definitely wanted to show you before we go into Q&A, because there is, I didn't think that I'd be able to finish in time in 50 minutes, because I also struggle doing it in the 60 minutes. So there is a lot of content inside of the slides that you can go through yourself. But there is one thing that I want to show you, is it's data that it's a tweet coming from August 2019, but it's still very much valuable these days. So remember when I said that works on my machine is not a valid excuse? This is Chris Hamill. He's one of the Power BI Cat team members that doesn't get up on YouTube and shout yo or swings with swords. He's one of those people that if he tweets or blogs, you usually know that it's going to be something insightful that not a lot of people think about, and it's going to be something really good. And he did a simple combination, a simple comparison of the Edge browser back then, which didn't have the Chromium kernel, which you have these days, and the Chromium-based kernel. So you see, for a simple report that's visually intensive, let's say, you can see that there's a difference of about 10 to 15 seconds on the same machine just by using a different browser. So this is Edge Dev versus Edge. now it's the same thing. But if you do the same comparison for Edge versus Firefox, if you do the same comparison versus Edge versus Safari, you'll also see these differences. And if you're using Internet Explorer as your browser, well, then it's probably still rendering that report 1.5 years later. But it all boils down to the fact that how capable is the browser of handling what is the browser capable of handling these, and that's what makes it so interesting to look at these different types of things. So I have a few, as I mentioned, there's a bunch of content in there that I didn't even think that I'd be able to get through, but it's in there for you to browse through as well. But there are some takeaways. There are some takeaways that you can take home with you. And I'll then get back to the questions that are in the Q&A window. So report performance, in my personal point of view, it should be thought of at design time. If you're doing certain things, make sure to test them as well. So that's not only a visually attractive report, but also a well-performing report. Because if you can do these tests and checks before handing it off into production, it'll be a bit better. Because if you can fix these things before going live, it usually means that it's not being used by multiple people. It's easier to fix these things. Make sure that the transformations you're using, that they're smart, done only once, and done as early on as possible. Modeling is key, meaning that star schemas really make a difference for Power BI, but also the fact that the browser and the hardware that the end user is using really make a difference to the report performance that they see on the end user side. I do also highly encourage you to create a personal set of best practices for Tabular Editor. You can start from the ones that are listed on the GitHub page. The GitHub link is inside of the GitHub link is inside of the slide deck as well. And well, keep reading, learn new stuff. Make sure that you read up on new things, and that you can make sure to keep learning. Because, like I said in the beginning, not everyone knows everything. Not even Paul Andrew. That's a guarantee. And it's important to keep reading these different things. So I'll make sure, I'm getting the link right now, to put the link to the GitHub repo that I put my slides on, to make sure that I'll share that in the chat window. And with that said, I'll go over to Q&A. Once more, there are a bunch of resources in there that you can go through. My social details are listed on the contact slide. And if you do have a question, then you can definitely make sure to get in touch with me through the socials. And I'll try to get back to you. But questions, Lukas, is there a way to list all the unused fields? So there are some calculated measures, but we finally won't be using all of these. And we need to remove the unused ones before deploying the finished report. Yes, there are a few options for you to do that. There is, in the list of external tools that I referenced, there is this tool called Power BI Cleaner or Power BI Helper that can help you do this. So Cleaner, Field Finder as well, or Power BI Helper. The thing is, with shared data sets, if you're splitting your data set and your report, or if you're making reports that are dependent on that one data set, it's a bit more tricky to find those cross-report dependencies. But using these tools can definitely help you get started with these. That's definitely. If that didn't answer the question completely, just put it in a chat window and I'll try to help something as well. So Tomasz said Power BI Helper, effectively, yes. GG, what are the principles I listed for a star schema in Power BI? Meaning that there is as well a link inside of the resources that guides you to the guidance on the Power BI docs for making star schemas. That's a very good starting point. If you want to go a bit deeper, it's based on Kimball methodology. So the Data Warehouse Toolkit by Kimball is also a very good start. And these are some things that can help you get started with these things. So Robert asked how to save data from Vertipack into the Excel file. It's through an Excel extension. I also saw someone mention the link. That's Tomasz also put a link in there. That's true. The link goes to VertiPack Analyzer. They explain how to connect to the model, but if you want to use your DAX Studio for it, it also does the same thing. If you open up DAX Studio and then go to, DAX Studio, and then go to the advanced and view metrics, it actually does the same, but a bit more simplified version, and it gives you the same of these metrics. It gives you the same things that I've been showing you, but it only connects to the current file that you have open, which is something to keep in mind. And you can have those same details in there with some highlighting, what's the cardinality, what's the size, these things. So they can really help you get started. And it's a bit more easy to get started. But like I said, I sometimes want to go looking into these compression details and the encoding details, and those currently are only inside of the Excel file. So to get started, definitely DAX Studio, Advanced, and then View Metrics to help you get started. Anonymous attendee, what about troubleshooting reports on the PowerBI.com portal? If you want to look at those, the way the visuals render, the only way you can do that is by downloading the report and looking at the same way as I've been doing now. If you want to look at the models themselves, you need to have either premium per user or premium, so you can connect to the XMLA endpoint and connect to the model directly. If you're using Power BI Pro, there is no way for you to manually connect to the model that's inside of Power BI with these tools. Or it's possible, but it takes some dirty hacks to start doing them, and that's not something that we're going to do now. Yep. Yeah, okay. So Robert, once more, how to save such data from VertiPack into the Excel file, if you follow the link that Robert put in there, the sqlbi.com/tool/VertiPack Analyzer, they explicitly explain it there as well. So if there are, I think that's all the questions. So if there is any more questions, definitely do put them in the chat window here or inside of the Q&A window. The GitHub link that contains the slide deck, I put it into the chat window so you can find it there. And then, so I have to click done. Okay. So if that's all, once again, I want to thank you for watching the session. Thank you for being here. And I'll put the details onto the slide one more time. If you want to reach out to me, if you've got any questions, reach out to me on Twitter or LinkedIn. And then if you want to send me an email, you can do that as well with the email address that I put there. That said, there's nothing more. Well, that's all I have for now. Thank you for watching the session. I presume that they put a feedback link into the chat window as well. My Polish is not that great, but if there's feedback, please do fill it in, because I'd like to know what you thought of the session. Enjoy the rest of the day, keep on learning, and then those of you that are sticking around for Paul's session, have fun. Those of you that aren't sticking around for Paul's session, well, you do need to stick around for the session. Thank you.